We've all done it. You look up at the night sky, spot a brief streak of light, and make a wish on a shooting star. But that light isn't a star at all. It's a piece of cosmic shrapnel. As it hits the atmosphere, the air in front of it compresses so violently that it generates enough friction to heat the rock to 3,000 degrees Celsius. Most of this debris originates in the asteroid belt, a massive ring of floating rocks situated between the orbits of Mars and Jupiter. Mars acts as a massive disruptor. As the planet moves through its orbit, its gravitational pull can yank these asteroids out of their stable paths, slingshotting them directly into Earth's trajectory. Before they can reach us, they hit our primary defense, a 640-kilometer thick layer of air. This atmospheric friction acts as a security shield, vaporizing the vast majority of incoming debris before it ever touches the ground. Entry speed depends on the angle. On the left, a meteor enters in the same direction Earth is spinning, keeping friction manageable. But on the right, a bolide strikes head-on against the planet's rotation, creating a much larger and more intense friction burn. While this shield protects us from thousands of daily impacts, it is a mathematical certainty that eventually, a rock will arrive that is simply too large to burn up. 60 million years ago, a rock the size of a city bypassed the atmosphere entirely, striking the shallow waters of the Gulf of Mexico. The force of that impact was equivalent to the detonation of 20 hydrogen bombs. The energy release triggered magnitude 10 earthquakes across the globe, while the resulting tsunamis physically reshaped the coastlines of entire continents. In the atmosphere, the blast drove local temperatures up to 200 degrees Celsius, instantly killing airborne creatures that were hundreds of miles away from the impact site. This shockwave also agitated the Earth's interior, triggering volcanic eruptions that filled the sky with toxic gas and radioactive dust. This impact did more than kill the dinosaurs. It effectively sterilized the surface. Only the small, subterranean creatures capable of hiding underground survived to inherit the planet. The kinetic energy from the impact was so massive that it traveled through the planet's core, eventually altering the Earth's crust on the opposite side of the globe. In East Africa, this tectonic shift pushed the land upward, creating a new mountain range that would change the region's climate forever. These new peaks acted as a geographical wall, blocking the moist monsoon winds that had historically kept the interior lush and green. Deprived of rain, the dense African rainforests began to die back, eventually transforming into the arid savanna and desert landscapes we recognize today. For the primates living in these shrinking forests, the trees were no longer a viable home. They were forced onto the ground to forage, favoring the individuals who could navigate the tall grass by standing upright. The asteroid strike didn't create humans instantly, but it removed the forests that primates relied on. By forcing our ancestors onto the ground, the impact set the environmental stage for bipedal evolution. The cosmic bombardment never actually stopped. Today, chunks of space debris successfully land on our planet every day. Every time a meteorite lands, or even when it burns up into fine atmospheric ash, it adds physical mass to the Earth. This diagram shows the effect of that extra weight. As the planet's mass increases, its gravitational pull grows slightly stronger, creating a subtle drag that slows down its rotational speed. While tidal friction from the moon does the heavy lifting, this accumulated mass is a contributing factor. Millions of years ago, the Earth spun fast enough that a day lasted only 18 hours. Today, it takes 24. As we continue to collect cosmic weight, the Earth's rotation will keep slowing. Eventually, our descendants will live in a world where a single day lasts 30 hours. Each landing is a microscopic adjustment to the variables that determine our planet's weight and its internal rhythm. Earth hides its history of violence well. Massive impact craters often fill with water, disguising themselves as peaceful, forested lakes. However, these sites occasionally undergo radical chemical shifts, like turning a startling pink, serving as a visible reminder of how an impact can change the composition of a landscape. For a clearer picture of this ongoing bombardment, you only have to look at the moon. Without an atmosphere to burn debris or water to hide the damage, its surface remains a battered record of every collision. A shooting star is the visible edge of a process that cleared the way for our species and continues to adjust the length of our days, 1 gram at a time.